Hey everyone, and welcome back. Okay, let's dive right into this. Today we're taking on what is, without a doubt, one of the most intellectually demanding topics in the Cambridge syllabus, Mastering Physics 9702, specifically nuclear fusion and nuclear fission. But listen, we aren't just sitting here memorizing formulas today. Think of this like making your mark on a canvas. You need bold strokes of creativity, but they absolutely must be backed by a rock-solid structure. We're going to look at the real academic benchmarks and exact examiner expectations so you can literally master the exam. If you've ever walked out of a paper feeling like you knew the material perfectly, but your marks just didn't reflect that, well, you are in exactly the right place.
So here's our highly structured roadmap for today's explainer. First up, we're tackling nuclear physics exam realities. Then we'll look at the top 3 examiner warnings. From there, we move on to the method mark strategy. Fourth is our core framework: deconstruct, solve, and evaluate. And we'll wrap up with frameworks for critical analysis. All right, Section 1, Nuclear Physics Exam Realities, the Core Challenge.
You know, the assessment objectives for nuclear physics target some really distinct, high-level cognitive domains. We are way beyond basic knowledge and understanding here. This stuff pushes heavily into application and intense critical analysis. The examiners want to see logical, structured reasoning. Which brings us to the massive elephant in the room. I want you to honestly ask yourself right now, why do students lose easy marks? I mean, you've studied the textbook, you know the difference between a nucleus splitting and nuclei joining together, so where's the disconnect? Well, principal examiners point out that students massively struggle with evaluating evidence and actually drawing solid conclusions. It is a huge stumbling block.
And the reason? It all comes down to superficial breadth versus analytical depth. Look, it is so incredibly tempting to just try and memorize raw physics facts, right? To spread yourself thin trying to cover every single definition and formula across a superficial breadth. But the assessment framework? It doesn't care about that. It strictly prioritizes analytical depth. Examiners are actively hunting for your ability to interpret relationships and draw evidence-based conclusions, not just regurgitate facts on a page. And hey, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving into Section 2, top 3 examiner warnings direct from the source.
We're counting down the top 3. Consider this your definitive insider list from the principal examiner reports of what absolutely not to do when you sit down for your paper. Think of me as your academic coach today. I'm pointing out exactly where the traps are hidden.
Here we go. Number 1. Examiners report that candidates constantly confuse cause and effect. You've got to know exactly what triggers a fission chain reaction, like the absorption of a slow-moving neutron, versus the outcome of that reaction, like the massive release of energy and additional neutrons. Number 2. Forgetting to check format and presentation. Guys, presentation follows strict conventions. Proper headings, correct terminology, clear annotation. If your format is a chaotic mess, your marks will be too. And number 3, giving answers that aren't specific to the given context. Those generic, copy-pasted textbook answers, yeah, they will not survive this exam.
Now, what's really interesting about this slide is this massive examiner alert. Listen to this direct quote. Candidates consistently confuse key terminology. Always define terms before using them in extended responses. This is a giant red flag for whoever is grading your paper. If you're writing a long response about nuclear fusion, please do not just throw around terms like binding energy or mass defect and assume the examiner knows that you know what they mean. Define them first. It anchors your analytical depth, and honestly, it secures those crucial foundational marks.
All right, Section 3, the method mark strategy, shifting your mindset. And look, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, back to it. The method mark strategy. Basically, this means marks are awarded for your structured process, your systematic analysis, and your clear working. It is absolutely not just about the final numerical answer. Think about it. You could calculate the precise, correct energy released in a fusion reaction, but if your working isn't systematically presented, you're going to lose the vast majority of the marks. Mastering this process is essentially the true cheat code for the exam, because the cognitive domains of application and analysis are what actually trigger the grading rubric in your favor.
So,
Here is the standardized sequence you need to adopt for systematic processing. It's 5 steps. 1. Identify the key elements from texts and tables. 2. Apply the relevant conceptual principles. 3. Execute the analysis with incredibly clear working. 4. Verify your results. And 5. Present them in the appropriate format. Look, if you make this exact sequence a habit, you build a safety net. A net that catches method marks even if you make a silly little arithmetic error at step 4.
Let's move on to section 4 and see how this builds. Deconstruct, solve, and evaluate. The execution framework.
This is exactly how you need to build your response on the actual page when you're staring down a complex nuclear physics prompt. Step 1. Identify the given information. Literally deconstruct the prompt. Step 2. Break the problem down into logical, manageable steps. Step 3. Solve it systematically using crystal clear notation. Step 4. Check for reasonableness. Ask yourself, does my calculated mass defect actually make physical sense in the real world? And step 5, make justified recommendations or conclusions based on actual evidence.
Okay, I want you to actively engage with this right now. We've got identify, break, solve, check, and make. IBSCM. Here's your memory hack challenge. Invent your own mnemonic right now using the first letters of these terms so you can lock this sequence in forever. Maybe something like intelligent brains solve complex mysteries. Whatever works for you. Pause the explainer for a second if you need to, write your mnemonic down, and commit this execution framework to memory.
All right, section 5, frameworks for critical analysis, reaching top marks.
And this brilliantly illustrates what we mean. When you're asked to compare concepts, like nuclear fusion and fission, you absolutely cannot just list facts. The rubric demands that you identify both similarities and differences. Plus, it is mandatory to use comparative connectives to bridge your ideas. Every single comparison has to be supported by evidence extracted from the data, and your conclusions must explicitly state the relative importance of your findings. It's a strict, rigorous convention. Mastering it, totally non-negotiable for top marks.
Furthermore, when an exam question asks you to evaluate the quality of physics data, you really need to drill down. You can't just write that the data is good or bad. You need to systematically identify the limitations of the data, like what assumptions were made during the experiment. Are there alternate interpretations for the trend you're seeing? And finally, what effect do those limitations actually have on your final conclusions? This right here is the analytical depth we talked about earlier.
So the crucial takeaway is this blueprint, which summarizes our entire methodology. Whenever you face a difficult nuclear physics problem, do this. Deconstruct the question. Extract the relevant data. Select your analytical framework, execute it with clear notation, and present your final answer using the correct, predefined terminology. If you follow this blueprint, you are demonstrating exactly the professional skills the examiners are desperate to reward.
Let me leave you with this final, provocative thought. As you go into your next study session and eventually sit down in that exam room, ask yourself, will your answer show superficial breadth, or will it show true analytical depth? The choice is entirely in your hands, and now you have the exact framework to make the right one. Keep practicing this systematic approach, master the method marks, and you will completely transform your performance. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.